Okay, morning. I'm Derek. So since my talk one that many people saying that I speak too fast to understand, so I'll try my best to speak slowly today. So the old story about the corals and the tiny symbiotic algae, but today I want to mention about the topic on the baseline dynamics. The dynamics means change, so it know it's a changing baseline. But here comes the problem. What is a baseline? So to give you the concept of a baseline, I start with a story about Peter. Wait, who's Peter? Oh, that's Peter. Peter is a diver, and he loves diving everywhere. And one day he meets a new reef. Wow, that is a gorgeous reef, beautiful. As a coral scientist, Peter wondered how many coral species are there in this reef. So he counted 1, 2, 3, 4, 5, 6, and he found that he got a new data. There are 11 coral species in this reef. After Peter got back to the land, he shared this information with his kid. The kid asked him about a question. He wondered, is the coral diversity increasing or decreasing? Peter stopped and think about it. Sorry, we can't answer the question now. Why? If you put one data on the feature, that is the 11 coral species, you can find that the feature tells nothing but the 11 coral species. We can't make comparisons unless we get more data. So if we have more data like the black dot shows here, you can see the previous data and we can average them to get a dashed line. So when we put the new data on here, we can easily know that it's decreasing, right? On the other hand, if the blue dot is above the dashed line, you can easily tell the biodiversity is increasing. The dashed line is actually what we talked about, the baseline. It is an imaginary line used as a starting point for making comparisons. That is, for scientists, we know when a coral, it's time to help them. When it is their coral coverage is decreasing. So the kid asked another question: would the baseline change? We have so many data. Do they change a lot? Yes, it can change. That is what we call the baseline dynamics. It means the changes of a baseline. But do they change in a pattern? We know that there are seasons, there are day and nights. So if we get a data, do they show patterns? Maybe. We may find patterns in the baselines, but not always, because there are other huge events happening in our environment. So in the baseline dynamic studies, our goal is to find the patterns of the baseline. In coral issues, baseline have been built on different scales. Like in globally, we know we have lost half of them in the world. And now we know that Xiaoliuqiu is a poor coral reef island now. And in the species scale, you can know that the population size of specific stony corals, and even within one colony, that the photochemical efficiency can be tested. That is how efficient their photosynthesis is. So we know that coral don't live alone. So the kid asks another question. How about inside the colonies? Will there be baseline changing patterns? Yes, the coral lives with so many friends like the Symbiodiniaceae, virus, fungi, archaea, bacteria, and others. These little friends play important roles in facing rising temperature. So the study now, we're trying to build the baseline dynamics of Symbiodiniaceae genera. That means we have different kinds of symbiotic algae, like this. The Symbiodinian have, you can see the family tree, and there are many types of them. When facing the rising temperature, some of them are weak. You can see the cladocopian. It got punched by the rising temperature, got a purple eyes. And some of them quite strong, like the Derustinium. You can see the strong arms over there. So in corals, they can host both at the same time, and they can change the types based on their needs and environment. So that's why we often find that coral don't respond to the heat the same way. That is, even colonies, different colonies with different symbiotic algae, like the Derustinium, they won't get bleached that much like this. It is still brown, but with cladocopian, you can see it punched down, so it got bleached. It's going to be white. So often that the coral species is much matters. So you can see the massive Poreus lutea performs better than the Acoporanana, the branching one. And even in the reef scale, that we can know that Wanli performs worse than Hobihu. Why? Because they have different experience. They have learned about the past. So the thermal history in this study we're trying to is defined as the experience of dealing with heat stress. That is, if a coral without the heat stress experience, you may see when facing the right center, oh my god, the water is so hot. And if you got an experience that you can like the chill coral over there, I'm cool with the change. So luckily we have two different thermal patterns reefs in Taiwan, in the southern Taiwan near the Kentin National Park. That is our Wanli and nuclear power plant outlet reef. So for Wanli reef, it is a thermally stable reef, and that means the temperature won't get much change, and it feels safe. And a thermally variable reef, that is our nuclear outlet reef, that is means the temperature will change in a day very huge. So for corals, living in a Wanli is like a happy home. Yeah, it's a peace and sound place. But if you live in a variable reef, that the coral might yell about, am I in hell? Yeah, that is. So this study trying to find the baseline of symbiotic algae in Taiwan. And we're trying to check the patterns, remember? So we wanted to see if the symbiotic algae would change from cladocopian to Durustinian, and if there are reef-side patterns. So we have two hypotheses now here, because changing the symbiotic algae is quite hard, and it's difficult. So we assume that the corals don't change the symbiotic algae across different seasons, but we'll find the reef sites and species-specific difference. So we picked 3 different study corals and collected data 5 times during 15 months. And you can see that we wanted to know if the specific symbiotic algae shows up. We use a coarse qPCR, that's a DNA test method. And we use some environmental data are needed because the temperature should be logged and nutrients should be analysis from the water sample. So in this study, it is a scale crossing study that the 2 reefs, 3 species, and 2 symbiotic algae. So as a result, we found that the nuclear power outlet reef is actually a thermally variable reef. That is, it changed much in temperature, and Wanli is quite stable. And for the water chemistry parameters, they show no difference between sites and seasons. And the thermal regimen was the main physical difference between these 2 reef sites. That means the temperature matters. And after reading, we're gonna check about qPCR results. We see that it is a nuclear power outlet reef here, and it's about Acropora. The yellow line is about the cladocopian here. The Durustinian is the black down here. So you can see the qPCR results. We see that cladocopian and Durustinian shows both in the Acropora in summer 2018. And in Wanli also in winter 2019, you can still see the small signal about the Durustinian. So we still say that because we only want to test if they show up. So they also host both symbiotic algae. So let's take a look about the seasonal trends that you can see here. So in the outlet reef about Acropora, there are 2 symbiotic algae. And you can see that different across the seasons. You can see the trend didn't get changed much, like that. It doesn't see much change. And also in Wanli, it is changed a lot. But if you look closely, you can look at the Durustinian, that the black lines. You can find that the Acropora signal in outlet reef shows earlier than the Wanli. So you can test that. The Durustinian was detected earlier in outlet reef than Wanli reef. And for the Symbiodiniaceae change in Posterior acuta, there are also 2 lines. Take a look, and you'll see the color seems to different, right? The black is up here, and the yellow is up here. So we find that the opposite pattern observed for the colonies between outlet reef and Wanli reef in Posterior acuta. They perform differently. And our last coral species, that is the Poreus lutea, we find that the symbiotic algae of the Durustinian also detected earlier in the outlet reef than in Wanli reef. So that is what we have found. So our qPCR results shows that all corals shows both types of symbiotic algae, but the Derustinium seems to stick to the thermally variable reef like this, and we didn't find the seasonal patterns. So we can say that it is the site and species specific patterns remain consistent across seasons. So for our two hypotheses, that we all accept that corals don't change their symbiotic algae across seasons, and it relates to their reef site and species. So in conclusion, that is my conclusion, there are tough home and tough coral, which means if you live in a tough home that in a thermally variable reef here, you will get more Derustinium performs and will become a chill coral that can tolerate with the heat change. And rather than in the Wanitong reef, it's stable, but it will get bleached and yelled, yeah, oh my god, the water is so hot. And lastly, we didn't find the seasonal trends. Thank you.